in statistical inference, we can make use of the procedures using which we can estimate the parameters by two procedures. One is known as the point estimation and other is known as the interval estimation. So students, if we are required to estimate the parameters of the simple linear regression model under the non-parametric analytical techniques, then we can make use of the Thiel's method that allow you to estimate the slope parameter by making use of the interval estimation approach. Now students, if we talk about the non-parametric procedure proposed by Mood that have provided the point estimation approach for estimating the slope of the regression model. But by making use of the Thiel's method, we can estimate the slope of the regression model by using the point estimation as well as the interval estimation approach. So students, in this module, I'll be discussing with you the interval estimation approach that we can use under the Thiel's method for estimating the unknown value of the slope parameter beta. So the parameters of the population, they may be determined by employing the point estimation approaches as well as the interval estimation approaches. And now for fitting the regression model, the parameters alpha and beta, students, that we are assuming they are unknown to us and we need to estimate them from the sample data. So to obtain a point estimate of beta first, all possible sample slopes will be formulated. And how they will be calculated, students? Sij, जो कि all possible slopes आप calculate करेंगे अपने sample data में से, it is simply the ratio of the deviation of yj minus yi divided by xj minus xi. And now students, you are given with two type of variables, yi's and xi's. जहाँ पे xi's क्या है, fixed constants हैं और yi आपके random variables हैं. तो अगर आप देखिए न्यूमरेटर में आप हर jth वैल्यू को उसकी जो ith वैल्यू उसमें से माइनस करें, where you are assuming that I has to be less than j. यानी कि आप S1 2 अगर आपको कैलकुलेट करना है, S21 कैलकुलेट करना है तो y2 minus y1 divided by x2 minus x1. So this is the first slope that you are going to calculate and you are assuming that this value is lesser than this value, not the actual observation, actually this subscript, because we are assuming that I has to be less than j. Once you have calculated all possible sample slope by making use of the y variable and x variable, so in totality there will be capital N, that means NC2 values that you will be calculating for all possible slopes. Once you have done that, the estimator of beta, which is denoted as beta hat, is actually the point estimate, that means the median of the Sij. So beta hat आप निकालेंगे once you have calculated all possible slopes, students. आप उनको arrange करेंगे from smallest to the largest, and then you will be picking up the most middle value if the number of values are odd, and if the number of values are even, तो आप those central values का mean निकालेंगे तो आपको median देगा of all possible slopes. And that median of all possible slopes will be assigned to beta hat. और अगर आप देखिए तो इस तरह से आप point estimate calculate कर चुके हैं under the Thiel's method. Now we'll be making use of this point estimate to calculate the interval estimation for the slope parameter. So students, why we prefer interval estimation over the point estimation? Because most of the researchers, they assume that interval estimation में आपके पास ज़्यादा margin होता है, that you will be actually estimating the required parameter compared to the point estimation. क्योंकि point estimation में we assume to calculate a single value, a single point that will be assigned to the parameter, whereas under interval estimation we construct the interval of values and we assume that our unknown value of the parameter is expected to lie within that interval with a certain degree of confidence. So the interval estimation approach for estimating the slope beta was developed by Thiel, and it must follow the assumptions of hypothesis testing procedure to construct the interval for the slope parameter. The method yields a symmetric two-sided 100 into 1 minus alpha % confidence interval. So the first step that you need to follow is to calculate all possible slopes Once we have done that, then we need to arrange the values of Sij in order of magnitude from smallest to the largest. From this array, the lower and the upper limits of the confidence interval for beta will consist of two values, beta hat L and beta hat U. So for the given n and alpha by 2, we will be finding S alpha by 2 from the Kendall's tower table. So students, आपने n और alpha by 2 क्योंकि आपको given होंगे, उनके लिए आप S alpha by 2 कैलकुलेट कर रहे हैं Kendall's tower 2 टेबल से, और उस alpha by 2 में से आप 2 को सब्ट्रैक्ट करेंगे. इस नए वेरिएबल को आप कहेंगे C alpha by 2. अब आपने क्या करना है, यू नीड टू कैलकुलेट फॉर द K. K क्या है? कैपिटल N, टोटल नंबर ऑफ ऑब्जर्वेशंस, minus C alpha by 2 that you have just calculated, dividing it by 2, you will be able to obtain this K. अब ये K students आपने क्यों निकाला? Because using this K from the sample data, so sample of slopes data, you will be able to calculate beta L hat and beta U hat. That means the upper and lower limit of the unknown value of the slope. So the lower limit beta L hat is actually the kth value of Sij, जो कि all possible slopes हैं जिनको आप arrange कर चुके हैं from smallest to the largest, counting from the smallest value in the ordered array. And the upper limit beta hat U will be calculated as it is the kth value of Sij when you count it backward from the largest value in the ordered array. So the confidence interval that you have constructed in a way for the unknown value of the beta may be written as the confidence interval beta L hat less than beta U hat, and it is equal to 1 minus alpha. So we assume that beta is expected to lie between beta L hat, which is the lower limit, and beta U hat, which is the upper limit. So this is the procedure to calculate the confidence interval estimate for the unknown value of the slope parameter beta.